number 9, the goal is to find sine of alpha minus beta. Now in this case, we don't have a specific angle that we're working with. We're working with right triangles instead. So you're going to have two pieces of information, one about triangle alpha and one about triangle beta. And that's where we're going to start. So for triangle alpha, you're going to first start by recognizing, well, first you need to figure out what quadrant you're going to draw your triangle in. So if you look, theta, or not theta, alpha is supposed to happen in between pi over 2 and pi. So if you remember, on your unit circle you have 0, pi over 2 is up top, pi is halfway around, so 180 degrees, and then 3 pi over 2 is down at the bottom, and 2 pi is one full revolution around that circle. So that means that for between pi over 2 and pi, that would put alpha into the second quadrant. So I'm going to go ahead and draw a little quadrant, my right triangle. And if you remember, your angle always is closest to the origin in that corner right there. So from there it tells us that, so this is all we need that information from. So now we don't actually need that information anymore because it's served its purpose. So now when you look at it from alpha, cosine is negative 1/3. So if you remember, we're just using basic trig, so SOHCAHTOA. So from cosine, or from alpha, cosine is negative 1/3. So that means that the adjacent side from alpha is negative 1, and the hypotenuse is 3. Now we know the 1 has to be negative because with these right triangles, the hypotenuse is never going to be negative. It's only going to be either base or the legs of the triangles. So before we move on, we need to figure out what that missing side length is. We're going to need to use the Pythagorean theorem. So negative 1 squared plus, we'll just say, b squared, you can really use any variable there you like, is equal to 3 squared. So we have a positive 1 plus b squared, don't mind my squeaky pen, is equal to 9. That's a beautiful 9. Subtract the 1, so b squared is equal to 8. Square root both sides, and once you simplify it with your little factor tree, circle of 2, cross 1 off. B, or that missing side length, is really 2 radical 2. So I'm going to go ahead and fill that in. Now, make sure you pay attention to whether it's positive or negative. Since it's in the second quadrant, and that's a y-coordinate because it's an up and down movement, that's going to be positive. So you can go ahead and leave it as 2 radical 2. Okay, I'm going to go ahead and erase my... Okay, so now we're going to do the beta triangle. So if we look here, beta, or that inside angle, is supposed to be in between pi and 3 pi over 2. So that's going to put us into the third quadrant, which means in this quadrant, both of those legs are going to be negative. That's a beta. Okay, so from here, sine is negative square root of 21 over 5. So the opposite side is negative square root of 21, and then the hypotenuse is 5. And again, we have to find that missing side length, so Pythagorean theorem, and use whatever variable you like. So we have a positive 21 plus b squared is equal to 25. Subtract the 21, and when you take the square root, b is going to equal 2. Now be careful, again, we're in the third quadrant, so when you label, it's really easy to just label it as a positive 2, but keeping in mind, when you go into the third quadrant, you're going to go back and down, so back is a negative direction, so that 2 is going to be negative. I'm going to go ahead and recopy these triangles on a new page, and hopefully do them a little bit neater, and then we'll actually go back now and find sine of alpha minus beta. Okay, so we're reorganized now, and now all we have to do is find sine of alpha minus beta. So what I did, I started by writing the general form for, and that's a difference formula, so if you look at your formula sheet, find sine of alpha, it'll look like alpha plus minus beta, and that's an alpha even though it looks like a 2. And since minus is the symbol that we're using, we're going to use the minus on the left side, and then if you look, the plus minus is situated on the same direction on the right side, which means we're going to use the same sign over there as well. Now just like we did with the sum and difference formulas with the unit circle values, where we had sine of pi over 4 and cosine of pi over 3, we're going to take in each one of these trig expressions is going to get replaced with the ratio, but this time the ratio is going to come from us looking up at the right triangle that it corresponds to and filling in the appropriate ratio. So for the first one, sine of alpha rather, you're going to look up at the alpha triangle, and then you're going to just write what the sine ratio is. So from alpha, which is that inside angle, sine is 2 square root of 2 over the hypotenuse, which is 3. Cosine beta. Now beta, we're going and looking at the green triangle. Cosine is adjacent, so -2 over hypotenuse, which is 5. We're going to subtract eventually. Next we want to find cosine of alpha. So again, now we're going to go back to this alpha triangle and write the cosine ratio. So adjacent, -1 over hypotenuse, 3, times, and then the last one, sine of beta. So again, saying beta, so go back to the beta triangle, and from beta, sine is the negative square root of 21, so opposite over hypotenuse, 5. And really all we have to do is simplify this. So if you look at the first two fractions, you're going to multiply them together. So multiply the numerators together. Now even though one of them has a radical and the other one does not, you can still multiply them together. The 2's would get multiplied together. So you'd have -4 radical 2 over, multiply the denominators together, so 15, minus, and then these two put together is just going to be a positive square root of 21 over 15. And then really the best you can do is just write it as one fraction, and then you'll be done. -4 radical 2 minus the square root of 21 all over 15. And then unfortunately for these, you cannot check these in your calculator, seeing as how we don't know what alpha and beta are, and we just have a general form for it up here. So this is a little bit different than the unit circle ones, where you could type in the original and then the final answer and compare them. But as long as you set up your triangles the right way, hopefully you're good to go.